A very good morning to one and all. Myself, J. Anusha, working as lecturer in physics at SS Government Polytechnic, Zahirabad. I am dealing with the subject applied physics. So that is for first year, second sem students. And the subject code for applied physics is 18 common to not 3F. And the topic what we are going to discuss in today's session is electricity and measuring instruments. And from this topic, for today's session, we'll discuss about electricity. Now, as you have seen in the first slide, that is our main chapter, the fifth chapter from our syllabus, electricity and measuring instruments. So we'll see the first part of this chapter, that is electricity. In today's session, we are going to discuss about introduction to electricity. Now, I am working under Department of Technical Education, Telangana. Now, let us move on to our class. The main objective of today's session, today's class is, on completion of this period, you'll be able to understand what is electricity, that is the introduction to electricity. And while learning introduction to electricity, we'll learn about definition of electric current and a very important law, Ohm's law, and its explanation. So what is electricity? See, electricity is a form of energy which is involving the flow of electrons. Now, before discussing about the electrons, the matter which is present around us is made up of atoms. Now, these atoms contain positive charged particles which are called protons and neutrons which are at center of the atom, and the center of the atom which is called as nucleus, and negative charged particles which are revolving around this nucleus are called electrons. Now, the atom contains equal number of positive charged particles and negative charged particles. The force between these positive and negative charged particles is balanced. That is, an atom is electrically neutral in its normal state. Next, when balancing force between positive and negative charges is upset by application of outside force, atom may gain or it may lose electrons. Now, thus gaining or losing electrons leads to movement of electrons, that is negative charged particles. The movement of flow of electron from one point to another point in a conductor is known as electric current, or simply it is known as electricity. So how this electricity is coming, or else what is the reason behind this electric current? That is because of some external force applied on the nucleus. The balancing force between positive and negative charged particles which are present in the which are revolving around the nucleus, it leads to flow of electrons from one point to another point in a conductor. Now what is Ohm's law? Now it was given by Ohm. Now according to Ohm's law, it gives the strength of flow of current in a conductor when potential difference exists between the ends of conductor. Now when we can see this Ohm's law? When there is potential difference across the ends of conductor in which there is flow of current. Now let us learn what is statement of Ohm's law. A very important statement. At constant temperature, the current passing through a conductor is proportional to the potential difference between its ends. Now if we consider a conductor which is having both the ends, at both the ends if there is potential difference, then the current which is passing through that is proportional to this potential difference at constant temperature. Now let us see how we can explain this Ohm's law. Here you can see a metal conductor which is having two ends. At the two ends you can see positive charge and negative charge. What it means? There is potential difference at the ends of conductor. Now here A and B are charged bodies. A is positively charged and B is negatively charged. These two are connected using a metal conductor. Now this A is a body having potential difference, having potential, positive potential, that is VA, and B is a body having negative potential VB. Now these A and B bodies are connected by a conductor. Now you can see in the picture we are connecting. Let me show you. This is the body A and this is the body B. Now these two bodies are connected with a conductor. Now what it means? These two are ends of conductor. At the ends of conductor, at one end we are having positive potential and at one end we are having negative potential. So there is potential difference across the conductor. Let the potential difference between the ends of conductor is VA minus VB, which is equals to V. Now the current which is flowing through this conductor is I. Then according to Ohm's law, the current is directly proportional to potential difference. So I is directly proportional to V. Now if we take it out proportionality, we'll get one constant. So that is R. So V by I is equals to R, where this R is electrical resistance. So finally, Ohm's law is expressed in terms of an equation that is V equals to I into R. Now here you can see we can represent this Ohm's law by using a triangle. Now you can see in a triangle we divided it into three parts. They are represented by potential difference, electric current and resistance. Potential difference is V, electric current is I and resistance is R. Now in the first triangle you can see we are expressing potential difference as V is equals to I into R. And in the second triangle you can see we are representing or we are expressing the equation for electric current I. You can see I is equals to what are remaining? V and R. Now you can see in the picture V and R related with a division mark. You can take it as division, and this is V by R. That is what we have written here. I is equals to V by R. And similarly in the third triangle you can see we are expressing R in terms of V and I. So where R is equals to V by I. Very, very, very useful triangle which is giving expressions for potential difference, electric current and resistance. Once again, remember these three formulas. Potential difference is expressed as V equals to I into R, and I is equals to V by R, and R is equals to V by I. Now what is unit of resistance? The unit of resistance is ohm. The symbol for resistance is ohm. Now what is ohm? The ohm is a resistance of a conductor when 1 volt potential difference is maintained and a current of 1 ampere flows through the conductor at constant temperature. Now what is the effect of temperature on resistance? In metallic conductors, the resistance increase on temperature increases. In semiconductors, the resistance decreases on temperature increase. Later on, in other sessions, we are going to discuss about this effect of temperature on resistance in detailed form. So you just remember, as the temperature increases for metallic conductors, resistance also increases, and for semiconductors the resistance decreases. Now what are limitations of Ohm's law? It is applicable to metallic conductors. The conductors that obey Ohm's law are called ohmic, and which does not obey, they are non-ohmic. So semiconductors and vacuum tubes are known as non-ohmic conductors. This is also we are going to see in next sessions what are ohmic and non-ohmic conductors. Now what we learned in this session, this is our summary. We have discussed the following. We discussed about electricity and we discussed about Ohm's law. The flow of electrons is simply electricity, and the relation between electric current and potential difference is expressed by Ohm's law. Now when we are discussing about Ohm's law, we got a constant, that is resistance. That resistance is expressed in terms of ohm. So let us see how much we learned in this session. Electric current is due to flow of atoms, flow of protons, flow of electrons, none of the above. Obviously it is because of flow of electrons, which are negatively charged particles. The direction of flow of electric current is in the direction of flow of electrons, opposite direction to the direction of flow of electrons, negative potentials to positive potentials, none of the above. So this is opposite to the direction of flow of electrons. Now Ohm's law gives the relation V equals to Ri, R by I equals to V, Vi is equals to R, or none of the above. That is V equals to R into I. Now resistance is expressed in volt, ampere, ohm, or none of the above. Now as this resistance is defined after learning about Ohm's law, the resistance is expressed in terms of ohm. Now here are some frequently asked questions. You may get a question, what is electricity? And state and explain Ohm's law. Thank you so much. With this, I am concluding this session. I hope you understood about electricity and Ohm's law. Once again, thank you so much for listening the class carefully.